Well, we're going through this quizzes right here, trying to help you out. And the first question is, what does CPCTC stand for? Well, the logic behind it is if you have two triangles that are congruent, then all of their angles are the same. So triangle 1 and triangle 2, all the angles in triangle 1 are the same as all the angles in triangle 2. And all the sides in triangle 1 are the same as all the sides in triangle 2. I don't know if these symbols are helping much, but the angles are the same and the sides are the same. So that's what this abbreviation stands for. Usually when we talk about side, angle, side, 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 angle, side, angle, 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 side, and hypotenuse, leg, this is to prove that the triangles are the same or congruent. So what this does is it goes the other direction. So if the triangles are the same, then all their pieces have to be the same too. And what does it stand for? Corresponding parts of congruent triangles are congruent. So corresponding parts of congruent triangles are congruent. What that means is, and like I said, the parts are the same for the triangles if the triangles are the same. Corresponding parts, the parts of the triangles, so the ones that link together, are the same of congruent triangles, of triangles that are the same are the same. So it's kind of repeating a little bit, but so that's what it means. And then just pick whichever one it is. What does SAS stand for? Well, it's our song. Side, angle, side, 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 angle, side, angle, 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 side, hypotenuse, leg. So I said it. Which one was it? What did I say when I said that? All right. What congruency postulate proves the triangle congruency here? All right. So what's our 5 sayings again? So make sure you're saying these also. It really helps to say them and write them down. So repeat after me if you haven't been doing so. Repeat after me. I'll give a space. So say side, angle, side. Side, side, side. Angle, side, angle. Angle, angle, side. Hypotenuse, leg. All right, I hope you're saying those after me. Which of these proves these triangles are congruent? Well, do you remember what I've told you to always look out for? When they're sharing a side like this, that's the reflexive property. It's kind of like a reflection right here. That's a shared side, so we give it tick marks. I wouldn't give it 1 because these already have 1. I'd give it 2 because they're sharing that side. So this is side 1 matches with side 1. We got an angle that matches. So the angle matches. And then we have side 2 that matches. So make sure you're going in order. So I went from side 1 through the angle to side 2. Can we follow that same path on the other triangle? Side 1 through the angle to side 2. So which one is it? What postulate would you prove these triangles to be congruent? All right. Well, do you remember what I said? I just told you whenever you see this, mark it. We call it the reflexive property. What's the reflexive property? That when they share a side, it works for both of them. It's kind of like a reflection. So they're sharing this side right here. What did I tell you to do? You mark it with tick marks. 1, 2, 3. So they're sharing that side. So they have a side 1 in common. They have a side 2 in common. And they have a side 3 in common. This is the easiest one. Hopefully you can recognize which one it is. Remember, say your postulates out to kind of help you practice each time. When do you use CPCTC in a proof? Well, this is if the triangles are the same. If these triangles are the same, then that means their parts are the same. All the angles have to match and all the sides have to match. Okay? So when do you use it? It's usually optional, but this is usually something that you would use at the end. But it could be totally used at the beginning. So if they gave you that the triangles are the same and you're trying to prove their pieces are the same, then you can go ahead and use the fact that this is the same in the beginning. Or if you have to go through and prove the triangles are the same to get to the parts, that's kind of at the end. So to me, it's an optional idea. So usually though, I guess they want to look at it as usually in these proofs, usually it's at the end. So you're making connections about the triangles to get to this fact of trying to prove that the sides are the same or the angles are the same. That's fine. But to me, it can happen anywhere as a math teacher, but that's fine. They're helping you get used to dealing with this. What does it stand for? Do you remember? What does it stand for? Something that starts with C, something that starts with C, P, then of, something that starts with C, something that starts with C, R, something that starts with C. Corresponding parts of congruent triangles are congruent. Say it after me. Corresponding parts of congruent triangles are congruent. What postulate proves these triangles are congruent? Well, side 3 matches with side 3. Side 4 matches with side 4. And then we have a right angle right here. We got an angle right here. So that's side 1, angle, side 2. Side 1, angle, side 2. What postulate proves these triangles are congruent? Do you remember what I told you to always mark first thing when you see this situation? Reflexive property. What's the reflexive property? When they share a side, it's good for both of them. All right. So we got an angle. So this is a right angle on this side. It's on a flat line. That means it's supplementary. So this angle has to be right also. So I got angle 1. I have the side, and I have angle 2 down here. Well, do we have that same pattern? Angle 1, the side, and then angle 2. Yes, we have that same pattern. What postulate proves what? What postulate proves these triangles are congruent? Well, what did I tell you to do every time you see it? Practice the word. Say after me. Reflexive property. What's the reflexive property? When they share a side, it works for both of the triangles or shapes in this case. Okay, so let's go ahead and mark what they have. So we got an angle right here, angle 1. That matches angle 1. We have an angle 2. That matches angle 2. So you went angle 1, angle 2, and then you have this side. Same thing, you have the side. Angle 1, angle 2, side. Angle 1, angle 2, side, going in order. All right, we got a little bit of a proof here. Let's see. Well, you have to kind of read this and make sense of it. Mark it on your shape if you need to. So let's go ahead and start this proof aspect. So given that triangle UXW and UVW are right triangles. So UXW, so that means this is a right angle also. And UWV are right triangles. So check, got that. Given that, and given that UX right here is congruent to UV. They gave it 1 tick mark. They gave it 1 tick mark. Okay, so check. They've done that also. Prove that angle X is the same as angle V. Prove that this angle is the same as this angle. Okay, well, here's that kind of similar to that last question. Notice the last thing they have here is the corresponding parts of congruent triangles are congruent. So if I can show these two triangles are congruent, then that means these angles match. Because angle X is in the middle, angle V is in the middle. So that because of the mapping, if I show the triangles are the same, then those angles are the same. And all the sides are the same that match. All right, so let's go ahead and check it out. So the first thing they did is they're stating the givens. So the givens are right triangles. Check. Then we have matching sides. We showed that already. That's given. Check. And then UW is the same thing as UW. UW, this one right here in the middle, is the same on both sides. What did I call that? Do you remember? Reflexive property. And then we can say that by side angle, side angle, that's the same thing as angle, side. You remember what I told you? No ass. Ass is not one of them, so that's not working. Oh, wow, but this is HL, hypotenuse leg. So a hypotenuse leg, they are right triangles. Those are the hypotenuses. We do have a matching leg. So if this wasn't a right triangle, we would not be able to prove it. But since it is a right triangle by hypotenuse leg, we are okay. All right, that's fine. So let's just go ahead and confirm that reflexive property is what they want. Transitive, well, let's just look. Transitive property, that's if A equals B and B, well, so transitive property, if A equals B and B equals C, then it's like you could jump from A to C, then A equals C. That's the transitive property. It's like a transporter. I always like to think of it like A equals B and B equals C. I can go A equals C. It's like you can cover up the middle one, right? And A equals C. That's the transitive property. That's what that is. But it's not transitive. It's reflexive. They're the same side. Yes, they are. But what is it called? And given, no, these are the things that are given, not the UW equals UW. So no, reflexive. Which is not a test to prove triangle congruence. We'll go through your song, and I've done it several times already, so just go ahead and see which one you think it is. Hey, you remember what I said about that? You can go either way. So let's just look side, angle, side, 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 angle, side, angle, 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 side, and hypotenuse leg. So let's take a look at this one. The SAA, is that one of them? Well, remember, you can go either way. So this is the same thing as AAS. AAS is one of them, so that one's okay. SSS, SAS, do you remember what I said? Go the other way here. ASS. No ass. Ass is not one of them. So that is not a test. So think about going both ways to kind of help you. And that really kind of helps to see why SAA works, even though in our song we say AAS. Remember, it doesn't matter the direction. All right, let's go ahead and see what this one turns out to be. OGD. OGD. We're going to complete what they're asking us to complete, a congruent statement. So this is what we call our mapping. Mapping. All right, so what's the mapping here? Well, it has to have that same order. They were pretty nice and they gave you the angles. So you can just match the angles. That's the easiest way. But it also has to follow that the way the sides work. So let's, oh, gee, they just, they even have them in exactly the same order. So don't mess this one up. Everything's in the same order. So it has to go O starts down here. So which one? O would be P. And then O to what? O to G. O to G. So it has to go over, I'll do the sides. It has to go over the 3 tick side. So it has to go over the 3 tick side. That's P to R. And then it goes over OGD, goes to D, goes over the 1 tick side. So it goes that way, and then it goes that way. So same thing, it has to go over the 1 tick side. The last one is C. All right, going with our proofs again. A little bit hard to read, but let's do our best. Fill in the missing parts on the proof. Given that ABC is an isosceles triangle with base of AC, okay, prove that angle A is congruent to angle C. All right, so ABC is an isosceles triangle. All right. So isosceles triangle by definition means you have matching sides and matching angles, but let's go ahead and just go from there. So ABC is an isosceles triangle. Okay, yes, they've told us that. BD is an angle bisector of angle B. BD is an angle bisector of angle B. Where's that? Where's that given? I don't see that given. They didn't talk anything about BD being some angle bisector, cuts it in half. So I'm not sure where that's coming from. All right, let's just go ahead and keep going. So if something doesn't make sense, we just move on, keep doing our best. BA is the same as BC. BA is the same thing as BC. That's what it means to be a isosceles. That's the one thing we know about definition of isosceles. Has to have matching sides. ABD and CBD are the same. So ABD, that's this one right there, is the same as CBD, is the same as this one right here. Okay, that's fine. That's because it's a angle bisector. Bisector means it cuts it in half, so those have to be equal. That's fine. I don't know where that's given, though. That's my question. And angle A, okay, and now we're on this one. BD is the same as BD. BD is the same as BD. Do you remember what I told you to call that? That's reflexive. Reflexive. And so that's that one. That's reflexive. REF. reflexive property, then triangle ABD is the same as CBD. So how do we know? Well, we got side, angle, side that matches. Side, angle, side that matches. Side, angle, side. That one works also. Vertical angles theorem. No, that's if you, this one. Oh, excuse me. That's if vertical angles is angles across from each other match. Transitive property, I talked about that one, transitive property. So they're just, this one is one that a lot of students don't remember. So that's, yeah, if A equals B and B equals C, then A equals C. That's not it either. Okay, so reflexive and side angle side. But like I said, I have an issue with this BD being an angle bisector. They never said that. That should be said if it's given. But that's okay. I'll let it slide. All right. What's the reason? All right. Statement that angle 1 is the same as angle 2. All right. So angle 1 is the same as angle 2. That's fine. XY bisects AXB. AXB got bisected. Well, yep, that's what it means to be bisected, is that these angles have to match. So that's when it is what it should be. That's called a definition. So that's the definition of bisect. Definition of angle, no, that's just what these are. Those a vertex or a corner where two lines meet. Definition of congruence is for everything to be the same. Definition of a midpoint would be a halfway place. So that's close, but you could have called this like a midpoint on if it were on a line, but it looks like it's pretty clear definition of bisect. All right, what's the reason? P is perpendicular to X. That's the perpendicular sign. Given that this is what you have, okay, then angle 1 is a right angle. Okay, well, do you remember what it means to be perpendicular? That's pretty much the definition of perpendicular, is that you're making right angles wherever they kind of meet at. So they're using this fact right here, definition of perpendicular. You wouldn't say definition of right angle because you have to use the fact that they're perpendicular. Definition of an angle, no. Definition of 90. They haven't gotten in 90 yet, so we would have to say it's because of this, because that's the only thing that they've given, is that it's perpendicular, so that's the definition of perpendicular. These are just a little bit tricky, like trying to use the definition idea. Last one. All right, let's see how we did. All right, more proof. What's the reason? What is the reason for step 3 of this proof? All right, well, to go through it, we just read this like a paragraph and we mark our shape as we go through it. So, excuse me, let's just go ahead and see what they gave us. Given that AB is congruent to AD. AB is congruent to AD. I start marking it right away so I can see it on my shape. That way things pop out a little bit more. AC is an angle bisector of angle BAD. BAD. So bisector. Anytime you hear bisector or midpoint, it's cutting something in half, and each half means they're the same. So every time you see bisector or midpoint, we would mark those halves as the same. So it's a bisector. So that means that one is the same as that one. Prove that ACD is the same as ACB. All right. They're also what? Remember what I told you to mark for that one right there? I'm sure that's probably what it's going to be. So just keep that in mind. All right. AB is congruent to AD. AC is an angle, a bisector of angle BAD. So that's given. All right. I've already marked it. So blank definition of angle bisector. Definition of angle bisector means that these angles are the same. So that and Oh, step three. These aren't any of those. Okay, so that's just definition of angle bisector, that those angles are the same. And AC is the same thing as AC. So this is the same on both sides. You remember what I said that's called? All right, and remember, vertical angle is where angles across from each other have to match. Given, it has to be given in here. It has to be one of these things with a given. That's why I was upset about that last one. Using a piece, they said it was given, but it was not in the statement. And proof, that doesn't make any sense at all. That's just what this kind of type of problem would be called. Reflexive property.